Good morning. Pronto. Good morning. My name is Mauro Madonia, and I am here today to present my work by title From Energetic to Transport, from Psiche to MAAT. Psiche is a stratospheric platform. In particular, it is an academic project because this airship is a basis for another airship, MAAT. MAAT is a disc-shaped airship composed by two airships. One airship is called the cruiser because it is in high altitude for the transportation, and the second airship is a feeder, and show is this airship. But MAAT project is another basis for another project, my project in this case, The.R.M.A. The.R.M.A is another disc-shaped airship, and this airship will be to use for relief on urban area. The first study for this airship is the Fluidynamic simulation, because it is important to understand the aerodynamic characteristic for optimize the shape of the balloon. In particular, I analyzed three shapes, but the second shape is not present in this slide because it is equal to shape number 3, but the central hole in the balloon is not present. I chosen the shape number 3 for The.R.M.A because the results show the better solution for CD, drag coefficient, and CL, lift coefficient. I optimized the simulation by considering two configuration, full configuration for the aircraft. In particular, one configuration has a spherical container for the infrared camera, and the second configuration has not this external container by avionic box. And but the infrared camera is in the avionics box, internal avionics box. So aerodynamic evaluation shows that the interference of these components on the aerodynamic of the balloon is important because the interference has the maximum value with the crosswinds. In fact, the maximum change of the total drag for the aircraft is 48%. But in the horizontal motion for the aircraft is 12%, about 12%. But the configuration B is the better of the configuration A. Another study is the mass ballast, because Terma is Airship, and the mass ballast so is important. But the mass ballast depends on air density and gas density internal of the balloon. But the air density and gas density depend on temperature, air temperature in the external of the balloon. So I used the International Standard Atmosphere model, but I corrected the pressure and temperature at sea level for better to estimate this parameter. In 1 year, there is one oscillation of the mass, and in particular, the minimum ballast is 5 kg, and the maximum ballast is 34 kg in the coldest day. Another important parameter for the aircraft, but in general for all aircrafts, is the performance of the airship in cruise condition, and this performance is evaluated by curve of the thrust or of the power and drag, aerodynamic drag, or the required power for the motion in cruise condition. By this graph, the maximum speed for the aircraft is 50 meters per second. Another important evaluation is load factors. To understand load factors and variation of loads in wind condition, because load factors are important for the international normative, and the wind conditions is important because the structures depend on the aerodynamic load and variation of the aerodynamic loads. So the normative gives a speed of the wind 7.6 meters per second at maximum cruise speed, and so the load factor and the vertical load factor and the vertical loads are more critical situation than other direction. I made other study of this balloon, and for example, definition of safety condition of a flight mission, analysis of the endurance according to the weight of battery and photovoltaic panels, and etc. I think that the possibility for future developments that to complete the realization of the aircraft no later than this April, and to assure and certify the aircraft, but this point is require a very long time, to 1 or 2 years, to try the aircraft in safe condition for the user, and finish to sell it. Thank you.
Excuse me, when you talked about selling it, is there a company which is interested in
this moment, no. Because this project has more important characteristic for the MAAT, but because the feeder will be realized in a scale, in scale, and the therma is very, very similar in this case. So I can study the characteristic of this Airship in similar situation of the feeder.
Okay, thank you very
But
much.
I think that it is possible to sell it wherever.
Okay, thanks again. Okay, so the presentations are over. We stop now, we have a break, and we start again for the last part at 2:30. So thanks again for attending this event.